Hello guys, in this video I will try to cover some questions about comparison test. First I want to tell you what is comparison test. First of all, I want to cover the comparison test properly. Basically I will try to cover the concept also. First of all, uh, what is comparison test? Let's say we have to integrate fx with respect to dx and the limits are a and b. And we have to integrate fx, but without doing the integration we can talk about the convergence or divergence of this integral. How? Just you have to take a neighborhood function which is looking very similar to gx, which is looking very similar to fx also. Let me give an example so that you can understand. So basically, let's say fx is equals to 1 plus x to the power 3. So basically, how we can take the gx? Let's say x cube is less than equals to 1 plus x cube. Point to be noted, a comma b should be greater than equals to 0. Both of them will not be equals to 0, because if we are talking about a equals to 0 and b equals to 0, then the integral will not exist definitely. Upper limit and lower limit will be same, so it is a line or kind of something like that. So this now 1 by x cube is basically greater than equals to 1 by 1 plus x cube. How we can write something like that? Let me give another example. Let's say 2 is less than 3, right? So 1 by 2 is greater than 1 by 3. We are reversing the inequality. Let's say we are taking 2 at the right side and taking 3 at the left side. So 1 by 3 is less than 1 by 2. And I'm just writing this thing like that. Hopefully you can understand. Now basically this is gx greater than equals to fx. Now comparison test is saying to us if gx will converge, if we are integrating gx with respect to dx from the same limit a to b, then fx will also converge a to b dx. Hopefully you can understand. Let's say the integration of gx with respect to dx is ig greater than equals to if, where if is basically nothing but the integration of fx with respect to dx with the same limits. Now basically, if ig will converge, then if will also converge, and if it will diverge, then if will also diverge. This is the point of view of comparison test. Now let's talk about some example so that you can understand what is comparison test. Basically something like that. So let's talk about some examples. So basically 0 to infinity cos x by 1 plus x square dx. You have to make this inequality where gx is greater than equals to fx. Fine. In that case we can see we are taking limits from 0 to infinity. That means cos x will vary from 0 to 1. So you can say cos x, hopefully it is visible more now. Cos x by 1 plus x square is nothing but less than equals to 1 by 1 plus x square. Why? Because cos x is varying from 0 to 1. That means, let's say, just assume this is I'm replacing cos x with a. Okay, now let's say a is 0.5, because we are talking about 0 to 1, so you can take 0.5. So 0.5 into, let's say, this term, this is basically nothing but 1 by 1 plus x squared. This is 1 by 1 plus x squared. Now let's take, this is z. I'm just explaining you don't need to show that. However, 0.5 into z less than equals to, this is also z. Is it true? Yes, definitely it is true. Basically it is z by 2, right? 0.5 means half into z means z by 2. and we are talking about z greater than 0 or greater than equals to 0, you can say. Why? Because x square is positive, 1 plus x square is also positive, so 1 by positive is also positive, so definitely z is a positive number, not equals to 0, you can say. However, so we can say something like that, right? Maybe into z into a it is. So now let's say a is 1, so z equals to z, satisfied. Let's say a is equals to 0, so 0 into z, which is basically 0, so 0 less than equals to z. Hopefully it is also visible. Now basically it is also correct that 0 is less than equals to z, because z is a positive number, so definitely 0 should be less than equals to z, right? Fine. So we can say that like cos x by 1 plus x square is less than equals to, hopefully it is visible, 1 by x square. Now we can say this is, let's say, gx, and this is the given function which is treated as fx. So gx, I'm just reversing it, gx, I mean fx is less than equals to gx, so gx definitely, gx will be greater than equals to fx. Hopefully you can understand. So if the integration of gx with respect to dx with the same limits, let's say 0 to infinity, in that case the limits are 0 to infinity, if it will converge, then the integration of fx, which is the given integral, it will also converge, right? You can understand. Now we have to integrate gx. Now we have to use the definition, right? So limit b is tends to 0, I mean what I'm saying, b is tending to 0, b is tending to infinity, big mistake, b is tending to infinity, 0, I'm replacing the infinity with b, because in every cases where you are dealing with a function which is bounded in the lower limit but the upper limit is infinity, then you have to replace the upper limit with b, and you have to take a limit where you can say b is tending to infinity. You can say, we can take a also, doesn't matter, I am just taking b, it's my choice, whatever the choice is, it doesn't matter actually. So b is tending to infinity, 0 to b. Now this is gx is basically 1 by 1 plus x square, right? 1 by 1 plus 1 by 1 plus x square dx. Now this is basically limit b is tending to infinity, this is basically tan inverse, this is basically 1 by a into, I mean the integration of 1 by 1 plus let's say a square plus x square, basically integration of a square plus x square dx. This is nothing but 1 by a tan inverse x by a. You can see the a is, I mean a square equals to 1 square, right? In that case you can say 1 is basically nothing but 1 square, so a is 1, so 1 by a means 1 by 1, and tan inverse x by a means tan inverse x. So this is the integration tan inverse x with the limit 0 to b. Now let's put the limits. Limit b is tending to infinity, this is tan inverse b, and we don't want to put the tan inverse 0 because tan inverse 0 is 0, nothing but 0. So basically tan inverse b minus 0. However, now let's put the value of v, which is tending to infinity, and tan inverse infinity is nothing but pi by 2. So pi by 2 is a constant and it is not equals to plus minus infinity. That means ig, which is nothing but the integration of gx with respect to dx with the same limits which are given in the question for integrating fx, right? So you can say ig is converging in a value which is, let's say, pi by 2. In that case the value is pi by 2, it depends on the question. However, so in that case ig is pi by 2, so ig is converging, that means if will also converge, because the question is not to find out the value of the integration. Maybe you can find out, it is your choice, but using the comparison test you don't have to find out the value of the integration, because it is too much complicated to find out the value. In that case it is too much complicated. You can take x equals to tan theta, but it will become too much complicated, so don't do that. Using the comparison test you don't need to worry about that. Something like you have to integrate 1 by 1 plus x cube dx. In the previous question you can take x equals to tan theta, maybe after a little bit calculation you can solve that question, but in that case it is next to impossible to solve that question in the exam hall, because it is too much tough integral. In that case, for checking the convergency, you have to use the comparison test, where you have to take gx is nothing but 1 by x cube, because because wait a moment, I am writing here, because 1 plus x cube is greater than equals to x, because let's say x is 0. We are talking about only positive quantity, be careful. Maybe x is 0, so 1 greater than 0. Maybe x is let's say minus 1. Sorry for a mistake. uh, Sorry for a mistake. Hopefully you can understand what I am saying. uh, Sorry for a mistake. 1 plus x cube is greater than equals to x cube, right? uh, let's say we are talking about positive quantity, so let's say the value of x cube is 0.2. So 1 plus 0.2 is 1.2, and here we can see only x cube is there, so this is nothing but, so 1.2 is greater than equals to 0.2. It is satisfying, so we can say 1 plus x cube greater than equals to x cube, and we are reversing it, so you will get something like that, 1 by 1 plus x cube, reversing the inequality. And why we are reversing? I had told you 2 less than 3, that means half greater than 1 by 3, right? Just remember it if you will face any kind of problem during changing the inequality symbol. Now this is nothing but the given function, which is fx, and this is nothing but the neighborhood function, which is gx. Basically, if we will plot the graph at the, let's say you are talking about any kind of app, then I will suggest you the Desmos app for plotting any kind of graphs. You will see both the graphs like fx and the graph of gx will be looking very similar, or something like that. They are looking very similar, or basically they are neighborhood graphs. And neighborhood means, let's say this is the graph of fx and this is the graph of gx. Let's say this is the graph of fx, and let's say this is the graph of gx. This is called neighborhood function, where the given function and the assuming function is the given function and the assuming function will be looking like very similar to each other. That's why they are called neighborhood function. This is the concept. Now let's talk about some very important question for semester exams or any kind of exam you if you have the syllabus of improper integrals. I will talk about two questions, and two questions are too much important and too much complicated. Not complicated. Basically, you have to understand a little bit so that you can, uh, talk about the convergence or divergence. Let's talk about the convergency. Basically, you have to find some conditions for convergency and divergence. Maybe it will come in. It will come in your exams. So, let's talk about some very important question. Let's move on to the next page. So in this question, you have to find out the conditions for convergency and divergency. So how will compute, or you can say define the convergency or divergency for a particular condition. So basically you can see there is an infinity. So first we have to do that, which is limit b tends to infinity 0 to b dx by x to the power mu. Now let's solve the integral. This is basically x to the power minus mu, x to the power minus mu into dx, and mu is a constant and mu is a real number. So basic integrations, hopefully you can understand. I'm not explaining this portion. So limit b is tending to infinity. Now if we are putting b, then it will be b to the power 1 minus mu minus 0 to the power 1 minus mu divided by 1 minus mu. So this is limit b is tending to infinity, b to the power 1 minus mu. This will be 0, so I'm not taking that, 1 minus mu, right? Now first of all, a thing which is very important, we don't have to deal with the denominator, we have to deal with the numerator only, because the denominator is constant. And from the denominator we can also say, which is mu not equals to 1, right? If mu will be equal to 1, then the answer is undefined, because if mu will be equal to 1, then uh, let's say constant, let's say this is also constant, constant by 1 minus 1, and 1 minus 1 is 0, and something by 0 is undefined, right? So we can say mu not equals to 1 first. Second, which is too much important, we have to deal with this numerator only. So this is 1 by 1 minus mu, limit b is tending to infinity, b to the power 1 minus mu. Now you can see infinity to the power something, right? Infinity to the power something, let's say a, will be equals to mm, will be equal to 1, will be equal to infinity, and will be equal to 0. When, first of all, when it will be 1, when we are talking about infinity to the power 0. But wait a moment, if we are talking about infinity to the power 0, then actually it is basically symbolizing the indeterminate form, which is infinity to the power 0. So cut it, we will talk about only this and this. Okay, so first of all, when infinity to the power something will be infinity, when a is a positive number, let's say a is 2, so infinity square is infinity, infinity cube is infinity. But when a is less than 0, let's say a is minus 1, just assume, okay, just assume it. If a is minus 1, then basically we can say infinity to the power minus 1, which is 1 by infinity. Now 1 by infinity is nothing but 0, right? 1 by infinity is 0. Hopefully you can understand. Now let's focus on the main question. You can see this is b to the power 1 minus mu. So the value of this will be 2. First of all infinity, and the second is 0. If it will be infinity, then the integration will not exist, or you can say integration will not converge. So when it will infinity, when the power will be positive, that means 1 minus mu should be greater than 0, then it will be infinity. Then it means the integral will not converge. Hopefully you can understand. So in that case we can see 1 minus mu, and I'm taking the mu at the right side, so 1 greater than mu, basically mu less than 1, right? When mu is less than 1 or equals to 1, because if mu not equals to 1, then it will converge, otherwise it will diverge, right? When mu is equals to 1, then it will also diverge. So for this to converge, what I'm saying, for this two conditions, the integral will diverge. So you can summarize both of them something like that. When mu less than equals to 1, then the integral, let's say I, will diverge. On the other hand, 1 minus mu, let's say 1 minus mu, this is limit b is tending to infinity, b is 1, the power of b is 1 minus mu, and it will be 0 when the power is negative. 1 minus mu is less than 0, right? If 1 minus mu is less than 0, that means mu greater than 1. That means this will be 0. So 0 by something is what? 0, right? So I is converging at 0, right? I is converging at 0. So when we are dealing with this condition where mu is greater than 1, then I will converge. Hopefully you can understand the total question, and hopefully you can understand the two conditions which we have to find out during solving any kind of this kind of questions basically. Now let's talk about another example where you have to deal with that kind of same method but with a different approach, a little bit different. So let's talk about another example. Let's move on to the next page. Now in that question you can see we have to deal with that integral. Now you can easily solve that integral using the basic methods. You will get something like 0 or something like -1 or something like that, or 1. Whatever the answer is doesn't matter actually. We have to uh, find out the conditions for convergence and also divergence. So let's talk about, first of all, we have to change the infinity with b. Limit b is tending to 0, infinity, 0 to b. This is 0 to the power minus px, this is dx. Now let's solve the integral gradually. So basically this is minus e to the power minus px divided by p. Normal integration, I am not explaining this portion. Now you can see we are putting the limits. We are putting the limits of x. This is minus b into p plus e to the power minus p into 0 divided by p. Very nice. Now this is limit b is tending to infinity. Well, this is nothing but 1, right? This is nothing but 1 because this is basically e to the power minus 0, which is 0. So e to the power 0 means 1, right? So this is 1 and this is minus e to the power minus b into p divided by p. Now we have to deal with that only. Now for your information, let's say this limit will exist for a particular condition, but this p will make this integration not existing. Why? Because like p, if p is equals to 0, then I will diverge. Simple. Basically constant by 0, which is infinity, right? I will diverge. Simple, right? Very simple. So this is the first condition for divergence. Now let's talk about two other conditions. So you can see now we are talking about p not equals to 0. Okay, fine. We are talking about p not equals to 0. Limit b tends to infinity, 1 minus e to the power minus bp. Now we have to deal with the numerator part only because denominator is constant. Maybe it is negative number, maybe it is positive number, doesn't matter at that moment. Now you can see 1 minus something. Maybe the value of this limit will be infinity, which makes this quotient diverging. On the other hand, it will be 0. So when it will be infinity, when it will be like 1 minus infinity, then it will be like minus infinity. Maybe it is infinity or minus infinity, doesn't matter. We are talking about infinity only. Now basically you can see when it will be infinity, when this portion is infinity, right? And e to the power, let's say this is a, will be infinity or will be 0, sorry, 1 and will be 0. Now we are not talking about this, we are not talking about 0, okay? Because in real domain we are not talking about 0 because in real domain e to the power a not equals to 0. As we are talking about only real domain, or you can say real analysis, so we will not deal with this. We will deal with only infinity and only 1. Hopefully you can understand. Now when it will be 1, when it will be 1, when e to the power b, e to the power 0, like when a is basically 0, right? When a is 0, then it will be 1. Very nice. So you can say that minus bp is 0, right? Now when minus bp is 0, that means p is equals to 0. Now we are not talking about this condition, right? Now basically we will talk about p greater than 0. When p will be greater than 0, then minus bp will be greater than 0 or less than 0. When we are talking about p greater than 0, then minus bp will be less than 0. Why? Because there is a minus symbol and p is tending to infinity, b is positive infinity, p is also positive, so there is a minus. That's why this is, let's say, 2 greater than 0, so minus 2 less than 0, simple, right? Something like that, if you can understand. So this, now as b is tending to 0, we have to take that, like p is less than 0, let's say p is minus 1. um, sorry for a mistake. B is tending to infinity, so minus p is less than 0, so p is greater than 0, right? From that, p is greater than 0. Now let's talk about a value. Just for example, I'm explaining you, that's why I'm using that, but otherwise we can easily say from the integration, like this is basically 1 minus e to the power minus bp by something. So if we are talking about infinity or minus infinity, then this portion will be infinity. And when it will be infinity? When the power of e will be positive. The power of e will be positive, then it will be infinity, otherwise it will not be infinity, right? So when bp will be greater than 0, right, when bp will be greater than 0, then like b is tending to infinity, so b will not be greater, I mean b will be greater than 0, right? B will be greater than 0 and p will be also greater than 0. Now we are fixing b as infinity, so I have to talk about p only. So when p is greater than 0, then this portion, I mean the e portion, will be infinity. There is a minus symbol with a 1. So this will be 1 minus infinity, which is minus infinity. So the answer of this limit will be minus infinity by p, which is minus infinity, which is minus infinity. So the answer of this integration is diverging when we are dealing with p greater than 0, right? Now let's talk about another portion, which is 1 minus e to the power minus bp will be uh, limit b is tending to infinity. Now basically it will exist when this portion will be 0 or this portion will be less than 1 or greater than 1 or something like that. Basically we can't take infinity, so we have to deal with something like that, it will not be equals to infinity, and definitely it is not 0, right? Because we are talking about only real domain, so e to the power something will not be equals to 0 in the real domain. So we have to talk about negative number or positive number, right? Hopefully you can understand. Now let's talk about p less than 0. Then it will be, when we are talking about p less than 0, then it will be e to the power minus b into minus something, right? Something minus negative number, right? So because we had talked about p greater than 0, so this is negative number into negative b, which is basically e to the power positive something, right? And the positive quantity is b into something, let's say a, right? And b is tending to infinity, so infinity into b is, I mean infinity into b is sorry, not b, it is a, is infinity. So this is e to the power infinity, e to the power infinity. 1 minus e to the power infinity is what? Infinity. I mean not infinity, actually minus infinity. So when we are dealing with p less than 0, then the integration will again diverge. I'm repeating this question in the next page again so that you can relate with the question again. So wait a moment. Basically we have to deal with this integration 0 to infinity, and this is limit b is tending to infinity, 0 to b e to the power minus px dx. Now basically this is e to the power minus px by minus p. Very nice. This is limit p is tending to infinity, 0 to b. Now this is minus 1 by p, limit b is tending to infinity. This is e to the power minus sorry 1 e to the power minus b into p minus 1. Now I am taking this minus symbol in the limit, inside the limit. So b is tending to infinity, 1 minus e to the power minus bb. Now we have to deal with that limit only. Now basically the value of this limit will be, let's say, infinity, specifically minus infinity, or 0, or something constant. When it will be infinity, then, or minus infinity, then it will not it will not what I'm saying, it will not converge, right? It will not converge. When we are talking about a or 0, then it will converge. Now we are not talking about 0. Why? Because if we are talking about 0, then basically p is nothing. We have to make this term 0, and for making this term 0, we have to make this portion e to the power something, e to the power, let's say, a. We have to make this 0, but a is a real number, right? A is a real number, so this is not possible. So we can't deal with that. We have to deal with constant or minus infinity plus infinity. Now let's talk about p greater than 0. Now a point to be noted, p not equals to 0. I mean, when p is equals to 0, this is the first condition for divergence. If p is equals to 0, so then it will be like 1 by 0, which is infinity, or minus infinity, right? Whatever. However, basically, p is equals to 0, it is the first condition for divergence. Now let's talk about p greater than 0. When p is greater than 0, this is limit b is tending to infinity, 1 minus e to the power minus b into p. So p is greater than 0 means p is basically nothing but a positive number. So minus b into p, minus b into positive, minus into positive, I mean, negative into positive is basically negative. So this is 1 minus e to the power minus something. Negative power is here. Negative power is here. So negative power means it is not negative. Actually, it is specifically minus infinity. Why? Basically, e to the power minus b into a positive number, right? Now if we are putting b is equals to infinity, then we will get 1 minus, I am explaining you, don't write in the question, or you can say at the answer paper. Okay, just write down, this is nothing but we are talking about constant part. So this is a by p. Specifically in that case a is 1. Okay, specifically in that case a is 1, because I had done that question, so I know the value of a. However, so in that case you can see this is minus infinity, right? So e to the power minus infinity is what? 1 by e to the power infinity. E to the power infinity is infinity, so this is 1 by infinity, which is 0. So 1 minus 0, which is 1. So the value of limit is 1 by p. So when p is greater than 0, then the value is converging. So this is the condition for convergence of integration of the given convergence. Okay, so this is the condition for convergency of the given integration. Now let's talk about p less than 0. When we are dealing with p less than 0, in that case we can say 1 minus e to the power minus b into negative something. Now this is nothing but 1 minus e to the power a positive quantity, and the positive quantity is nothing but infinity. So this is what? 1 minus e to the power infinity. Now e to the power infinity is infinity, so 1 minus infinity. Now 1 minus infinity, 1 is neglecting, I mean I am neglecting, 1 is being neglecting, right? 1 is neglecting, what I am saying, we will neglect 1. Basically 1 is nothing in front of infinity, I mean minus infinity, so this is minus infinity. So this is the condition of divergence. So I'm repeating again, when we will deal with p equals to 0, then I will diverge. When we will talk about p greater than 0, I will converge. When we will talk about p less than 0, I will diverge again. So for divergence, the condition is, we are summarizing the condition, which is p less than equals to 0 for diverging, and p greater than 0 is for converging. This is the condition. Hopefully you can understand this question. This is all for today. Now in the next video I will try to cover I will start the gamma and beta function. So thank you for watching my videos. If you feel helpful after watching, then subscribe if you want, comment if you want, and like if you want, and share if you want. It's your choice. Goodbye.